Welcome back to eCoreAcademy, everyone. My name is Anita and I'm one of the teachers and co-founders here at eCoreAcademy. As you can see, we have a new Algebra 2 lesson out, and this is going to be a segue from our last lesson on just basic polynomials, linear factors, zeros, into more so factoring these polynomials. Like I said before, these polynomials unit will be looking at every polynomial with a degree of 3 and higher. So cubics, quartics, quintics, I said to expect all of that. But now we'll specifically be focusing on cubics. So that means when you have a leading term, and it has an x value that is cubed. So that is a cubic. This is your cubic. So that's really going to be the main focus of today's lesson. As you can see, we're going to do an introduction to factoring cubes. In this scenario, we're going to have two terms. We're going to call them a cubed and then b cubed. And they're going to be either separated by an addition sign or they're going to be separated by a subtraction sign. So this is going to be called the sum and difference of cubes, and we're going to learn how to factor cubes when they're in this form a cubed plus b cubed or a cubed minus b cubed. So like I said before, we already know how to factor quadratics. We use the guess and check method, we used completing the square, and we use the quadratic formula. But how are we going to apply that to cubes? So what do we need to know so that we can factor cubes? Before I get into the lesson, I just wanted to reference the joke I had up on the screen. You see y and z, and they say, oh my gosh, they've cubed x. And if you see the x, like the actual x that was drawn, they took a bunch of little cubes, like the shape, the three-dimensional shape, and they arranged them so that it formed an x. So the x is like, so this is not my style. So that's where you get that x cubed. It's actually the physical cube, like the shape. So I thought that was kind of funny. Before I get into the video, I'd really appreciate it if you all could like, subscribe, hit the post notification bell, comment down below, and share using our socials. All right, let's get right into the first slide. So in this slide, we're just going to start off with a problem. We're going to see how do we make a cube. So in this problem, we're given two expressions in two different sets of parentheses. We have x plus 2 and x squared minus 2x plus 4. We're asked to find the following product, which means we're multiplying these guys out. So here's the solution already pre-written. If you want to copy it down, you can pause and go ahead, feel free to do so. But I'm going to go through it again with you right now. So the first thing I'm going to do, when I see these two expressions, I'm just going to rewrite them so I can start from scratch. So it's x plus 2 times x squared minus 2x plus 4. Pretty simple. And what we want to do, remember, with quadratics, what we did was we would FOIL. So we want to use a similar method. In this case, we have a linear term because you see that x to the power of 1 times a quadratic because this is x squared. That's the leading term. So foiling is not exactly going to work because in the second set of parentheses, we have 3 terms instead of 2. But I just want you to keep in mind that same concept where we're going to be distributing each of the terms in this parentheses. So we're going to be distributing the x and then distributing the 2 amongst the 3 terms in the second set of parentheses. So first, let's do x times x squared. That is going to give us x cubed. Then let's do x times negative 2x, which is going to give us negative 2x squared. X times 4, easy, plus 4x. And remember, pay attention to all your signs. 2, then we're going to move on to 2, and we're going to distribute that amongst these 3 terms. So 2 times x squared is going to give you positive 2x squared. 2 times negative 2x is just going to give you negative 4x. And then 2 times 4 is going to give you the constant term of 8. Okay, so let's look at this long polynomial that we have, and we can see that we simplify it because we have like terms. So if we look at the negative 2x squared, well, are there any other terms? So this is one term, another term, another term, another term, another term, last term. So are there any terms that also have an x squared? Well, we have a 2x squared here, and if you see negative 2x squared plus 2x squared is going to give us 0. So technically these cancel out. Let's move on to our linear term, 4x. Do we have any other x terms? We have a negative 4x. 4x minus negative 4x is equal to 0, so these also cancel out. And if you see, all that we are left with at the end is x cubed plus 8. And I want you to just take note of the fact that each of these terms are actually perfect cubes. X cubed is the perfect cube of x, and 8 is the perfect cube of 2 because 2 cubed is equal to 8. So just keep that in mind as we go to this next slide where I'm going to be explaining how are we going to be factoring cubes, and I'm going to also be introducing another method called grouping. Okay, so what we just looked at with that example I'm just going to rewrite it at the top, where we simplified what was in those two parentheses, and we got x cubed plus 8. That was called a sum of cubes because, again, sum is addition, and we have these two terms separated by an addition sign. And just like we did with that last problem, we're actually going to be doing the opposite now. So we're going to be trying to factor both sums and differences of cubes. So in the problems that we're going to be doing, we're going to be given something like x cubed plus 8, and then instead of trying to multiply it out, we're going to be trying to break this cube into its factors. We're going to be looking at the sums and differences. So we're going to have situations where we have two cubic terms separated by an addition sign, which is a sum of cubes, but we could also have two cubic terms separated by a minus sign, which is a difference of cubes, because when we work with subtraction, we're talking about differences. Okay, so how are we going to factor cubes? So these are two key formulas that you must memorize. Trust me, you need to know these. You need to memorize these so that on assessments, you know exactly what formula you're using to factor these cubes. Also, this even carries into pre-calculus and calculus, so you must memorize these. And they're honestly not too difficult to memorize because they're pretty straightforward. Both of these are literally identical, except there's two sign changes. Okay, so this first one here is a sum of cubes. So I'm just going to write sum next to it because as you can see, we have the term a cubed. We have some term a cubed, in our example is x cubed, and we have another term b cubed, which in our example is 8. And when we're adding them together, we're working with a sum because of addition. So if we're adding two terms that are perfect cubes together, we can factor these as a plus b. So we would take the cube root of whatever a cubed is, we take the cube root of whatever b cubed is, we would add a plus b, and then we would multiply that times the quadratic of whatever a is, but then squared minus a times b plus whatever b is squared. So you're just going to have to memorize this. You can just think of it as you're working with all addition signs. You're going to have to memorize. This is pretty straightforward, the a plus b. I think that's the easiest part to remember. Remember, you're just using an a squared term and a b squared, so you're squaring both the a and the b. This middle term is always going to be ab, so the two the a and b multiplied together. All you got to keep in mind is the sign change here. You're going to have a negative, so you must keep that in mind because you must be very careful with your signs or else you're not going to get the right answer. So keep that in mind. Here, on the flip side, we are working with a difference of cubes. So difference of cubes. That is because we have our a cubed and our b cubed, but instead they're separated by a minus sign for subtraction, difference. So if you see, it's literally the exact same thing. We start off with an a and a b linear terms in our first set of parentheses. Then we have a quadratic in our second set of parentheses with a squared, an ab term, and a b squared term. So literally the exact same thing as the sum. However, there's a sign change. In the second set of parentheses, you see those are all addition signs, so we don't have a minus sign in front of the AB term. However, we do have a minus sign between the A and the B in the first set of parentheses, so you just got to memorize that. I hate to say it, but you just have to memorize it. And if you see, this kind of reminds me, I was thinking about it earlier, of difference of squares. And I don't know if you all remember that from our quadratics unit, difference of squares. It was where when we had two very numbers, a squared and b squared, and they're separated by a minus sign. We could factor this as a plus b in one parentheses times a minus b, if you remember that. And I think that reminds me a lot of the sum and difference of cubes. So if you want to think of it that way to help you. So here's a cubes table, and I just wanted to throw this in there just so you all know that you should make sure that you know these basic cubes. So, whoops. That was supposed to come after, but yes, you're supposed to know these basic cubes. In this chart, as you can see, I made a basic chart of the numbers 1 through 10. This is actually flipped, sorry. So this here should be x, and this here should be x cubed. So sorry about that. So this is our x term. For example, in this case, it's 1. 1 cubed is 1. 2 is our x term. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1000. Must you memorize these? No, it's not mandatory, but trust me, especially if you're doing a timed assessment and you're working with big numbers, it would really benefit you to memorize at least 1 to 10. And it's really easy. I think you all are very capable of doing that. So make sure you just review this table. Lastly, we're going to talk about grouping. So when does grouping come into play? So grouping is a method that you will use with factoring. So what you're going to do is you'll often use grouping when you have polynomials containing 4 or more terms. If you guys remember, perfect standard form calls for a cubic with an x cubed term plus an x squared term plus an x term plus a constant. I'll call the constant c. So this is a perfect cube. Obviously, we're not working with that in all situations. Like up here, we don't have an x squared term or an x term. But in this case, we have 4 different and remember, they're going to be coefficients in front of these x's. I just wrote them like that. But grouping helps us kind of, separate these guys out however we want to. We can separate them like this, however we need to, depending on the situation, depending on the coefficients. So grouping is often used when you have polynomials with with 4 or more terms, because you can't just factor them normally like you would with a 3-term polynomial like you did with quadratics. So you often use grouping to help you split the 4-term or more polynomial. Then you'll GCF out of each of these sets of parentheses however you arrange them based off the problem, and then using those GCFs you will rewrite it as factors. So that's all about factoring and all the information I had to kind of spew at you. So let's get right into a series of problems. I have 6 for us. The first 3 are going to be on factoring cubes using the sum and difference of cubes formulas that we found, and then the next 3 are going to be based off of grouping. So let's get into the first example. We're going to be factoring a cube here. Problem is pretty straightforward. We have got 125x cubed minus 27y cubed, and we're going to just be factoring the following. Keep in mind that we're working with 2 different variables, x and y. Doesn't really complicate anything at all when it comes down to factoring. But just keep that in mind, because if you make a mistake with the variables, like for example, if you accidentally write them both as x or both as y, that will get you to the wrong answer, so just keep that in mind. Here's the solution pre-written for you. I'm just going to be running through that exact same solution again. Alright, so what I'm going to first do is I'm going to rewrite the problem. 125x cubed minus 27y cubed. Keep in mind, again, the variables. The first thing I want to do is I want to understand what am I working with. So obviously I see that these are both cubes. 125 is the cube of 5. X cubed is the cube of x, 27 is the cube of 3, and y cubed is the cube of y. So I know I'm working with a difference of cubes, again, because I have the subtraction sign. So I'm going to write out my formula for that. A cubed minus b cubed. Again, I memorized these, so you guys are going to have to do the same exact thing. Equals a minus b times a squared plus ab plus b squared. Okay, so let's break down what I have so far in the problem. In our case, our a cubed term is equal to 125x cubed. That's what we've been given in our problem. And our b cubed term is equal to 27y cubed. That's, again, what's been given in the problem. What we want to do is we want to figure out what just a is, because in this case, if we just have what a is, it's easy for us to manipulate a so that we can get a as a linear term, a squared, a times b, and we want to do the exact same with b. So we want to take the cube root of a and then the cube root of b. So how are we going to do that? So a is just going to be equal to the cube root of 125x cubed, because in this case, a cubed is equal to 125x cubed. So if we're taking the cube root of a cubed, we're also taking the cube root of 125x cubed. So if we do that, the cube root of 125 is 5, and the cube root of x cubed is just going to give you x. So that would be a. A is equal to 5x. B, on the flip side, is equal to the cube root of 27y cubed. The cube root of 27 is equal to 3, and then the cube root of y cubed is equal to 3y. So b is equal to 3y. All right, so now we got to rewrite. We got to use 5x and 3y, and we got to rewrite it in terms of a minus b times a squared plus ab plus b squared, which are going to be the factors. So in our case, how I would write this out is we've got 5x, right? And we're cubing it to get 125x cubed. So here, this 5x just by itself is going to be our a term, minus our b term, which is 3y, and we're cubing this to get 27y cubed, and this is going to be our b term. So how are we going to write it in terms of factors? Well, a minus b is going to be the first set of parentheses, so we're going to have 5x minus 3y times a squared. Well, 5x squared is equal to 5x times 5x. 5 times 5 is equal to 25, and x times x is x squared. So we're going to have an x squared plus AB. So AB is equal to 5x times 3y. So 5 times 3 is 15. X times y is xy. And then lastly, b squared. B is equal to 3y. 3 times 3 is 9. Y times y is y squared. So this here is going to be our final answer. So that is that difference of cubes factored. All right, so let's move right along to the next problem. Again, another factor in cubes, and here's the problem. We're going to factor the following. It's 4x cubed minus 32. Again, what kind of throws you off with this problem is that if you look at both of these terms, they're not perfect cubes. If you take the cube root of 4x cubed, we're going to get x times the cube root of 4. It's not going to work out really pretty, and neither is 32, but I'll show you what we're going to do in this situation so that we can kind of force a factoring of cubes. Also, there's a minus sign, so there's going to be a difference of cubes. So here's your solution ahead of time if you just wanted to look at it. And again, let's run through this together now. Okay, so I'm going to write this difference of cubes that we have 4x cubed minus 32. Well, right now it's not a difference of cubes, but because of the minus sign, it's going to work out to be a difference of cubes. So what we're going to do is we're going to GCF. Remember, whenever we're doing any kind of factoring, first thing you want to do is GCF. So you want to pull out the greatest common factor between the whatever terms you're working with. In this case, we want to pull out the greatest common factor between 4x cubed and 32. This is just going to make your life so much easier because then you'll be able to use a bunch of other tricks. Like, for example, right now we can't use the sum or difference of cubes formulas because these aren't perfect cubes, but by pulling out a greatest common factor, as you will see when I work through it, we can actually force a factorization through the cube formulas that we learned. So if you look at both of these, this is a constant term, so we can't pull out any x in our GCF because the second term doesn't have any x. However, if you look at the coefficient of 4x cubed, it's 4. We can pull out 4 from both of these because 4 goes into 32. It's a factor of 32. So if we pull out 4x cubed divided by 4 is going to leave you with x cubed, which, bingo, is a cube. And then if you pull out 4 from 32, you're going to get minus 8. And that, again, bingo, 8 is another cube. So we're pretty much going to be working with 8x cubed minus 8. And then our final answer, we cannot forget, we need to put a 4 in front of the two sets of factors that we find. All right, so let's get right into this. First, what we want to do is we want to write out what formula we're going to use. This is a minus sign here, so we're going to be using difference of cubes. So a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Again, just going to have to memorize that. Let's identify what our a cubed term is and our b cubed term is. So a cubed, in this case, we're focusing on this set of parentheses right here. Our a cubed is going to be equal to x cubed, and our b cubed is going to be equal to 8. All right. Next, what we want to do is we want to find out what just a by itself is without the cube. So we're going to cube root the x cubed and the a cubed. We want to find out what b also is by itself. So we're going to cube root the b and the 8. All right. So a is equal to the cube root of x cubed, which is just going to be equal to x. And b is equal to the cube root of 8. And if you remember your cube roots, 2 times 2 times 2 is equal to 8. So the cube root of 8 is equal to 2. So now we can rewrite this as x cubed. This is our a term here, because x to the power of 3 is equal to x cubed, minus 2 to the power of 3, which is going to give us 8. And 2 is our b term. We can rewrite this as a minus b. A is equal to x, b is equal to 2, so x minus 2. Oops, and I almost forgot, we got to throw the 4 in front of it because that was our greatest common factor. You must not forget that. It was up here, right here. All right, and then we got to move on. A squared is equal to x squared. A times b is equal to x times 2, so that is plus 2x. And then b squared is just 2 squared, which is equal to 4. So this right here is going to be our answer. Make sure, again, you include that 4 in the beginning to get the right answer. Moving on. This is going to be our last factoring a cube problem. I know you're so relieved. Okay, so last problem. Factor the following. X cubed plus 8y cubed. To the 6th power, sorry. Okay, let's just show you the solution real fast. That's the solution for you. And then let's get into me doing the solution for you. Okay, I'm going to rewrite this problem, x cubed plus 8y cubed. If you look at it at first glance, you're probably thinking, yeah, x cubed is a perfect cube. But is 8y cubed 8y to the 6th power a perfect cube? Well, I'll show you how we're going to prove that, or disprove that. So first, what we want to do is we want to look at what are we working with. Are we doing a sum or difference of cubes? Because there's addition, we're doing a sum of cubes. So I'm going to write the formula for that. So a cubed plus b cubed is equal to a plus b times a squared. Remember the minus sign because this is the sum of cubes times plus b squared. Okay, so this is the formula we're going to be working with. A cubed in this situation is equal to x cubed, and 8y to the 6th power is b cubed. And we're going to be trying to find out what a is and b is by cube rooting x cubed and 8y cubed. 8y to the 6th, sorry, I keep saying 8y cubed. A is going to be equal to the cube root of x cubed, which again is just equal to x because x times x times x is equal to x cubed. And then if we look at b is equal to the cube root of 8y to the 6th. So let's think of 8y to the 6th. It is one term, but let's split it into 8 and then y to the 6th. Well, the cube root of 8, as we know, is 2 because 2 times 2 times 2 is equal to 8. And then remember with exponents, when we have y to the 6th, by exponent rules, we're going to divide the 6 by the 3 when we put it in there, because this 3 is in the radicand, it is our index. So we're going to divide 6 by 3 and we're going to get y squared. I think we do exponent rules later on with rational expressions and equations. So don't worry if you don't completely understand that. We did go over in 8th grade algebra 1, I believe, but don't worry about it. Just know this for now. We're dividing the 6 because it's an exponent by the 3, which is the index. Okay. So 2y squared. So that is going to be equal to b. We're going to rewrite this as x cubed, with x being our a term, plus 2y squared, all to the power of 3, because that is our b term. And this is going to be equal to, well, a plus b, so x plus 2y squared times a squared, which is just going to be x times x, which is x squared, minus a times b, which is x times 2y squared, which is going to give us 2xy squared. We're pretty much just putting them all together. And then b squared. So b squared is 2y squared. 2y squared is pretty much equal to 2 times y squared times y squared. So 2 times 2 is 4, and y squared times y squared is y to the 4th. So this is going to give us our final answer, and that's how we got there. Hopefully you're getting the hang of this by now. All right, so now let's go over grouping. So we're going to factor this problem by grouping, and we're going to factor the following. 63x cubed plus 54x squared minus 105x minus 90. As you can see, this is a polynomial. It's cubic, but it has 4 terms. So we're not working with a difference or sum of cubes anymore. We're working with 4 different terms. So you'll see how we're going to use grouping to solve this, and that's your solution if you want to just go through it now. All right, so I'm going to run through that again with you. First, I'm going to just rewrite my polynomial. I always do this just so I get a feel of what I'm working with. So 63x cubed plus 54x squared minus 105x minus 90. These are some pretty big numbers, but don't get intimidated. Okay, first thing we want to do is we want to group them. So what do we mean by group? Well, if you think of it this way, and if you're in class and you're doing group work, well, your teacher might have a class of 20 students, including you, and you're being split into smaller sections. So it's almost easier for the teacher to see, okay, these 5 students are working together, these 5 students are working together, etc., etc., instead of having all 20 students just work together at the same time. That is chaotic. So that's what we're pretty much going to be doing with this polynomial. We're going to be breaking it into 2 groups, and using those 2 groups, it'll be easier for us to GCF and then come up with our final factors. So what we're going to do first is we're going to break these into 2 groups. Luckily for us, it's put in like an arrangement where it's easy for us to break it into 2 groups. In some cases, you will have to rearrange the polynomial so that you can break it into 2 groups. But in this case, we're going to break 63x cubed plus 54x squared into 1 group, and then we're going to put negative 105x minus 90 to the other group. The reason we group these are because these two terms, as I'm going to show you, have a common factor, and these two terms have a common factor. So you're always going to be looking for which two terms can I pair up that have a greatest common factor. And these two work together the best, and these two work together the best. And I know it might be a bit awkward, or it might be kind of out of your comfort zone right now, but you will get used to just looking at a polynomial and knowing which terms go together when you're doing factoring by grouping. Next thing we want to do is, let me just erase that quickly. The next thing we want to do is we want to identify what is the GCF of each set of parentheses. Well, what is the greatest common factor between these two terms here? Let's first look at the coefficients. This is what I always do. I look at the coefficients, and then I look at the x terms after. Even though this is all one term, we look at the coefficient, and then the x is after. So let's look at 63 and 54. What is their greatest common factor? Well, this goes back to like 6th grade math. Well, if I look at both of these, their greatest common factors are actually 9. 63 divided by 9 is 7. 54 divided by 9 is 6. That is the greatest factor that these two numbers share. So it's going to be 9, but we can't ignore the x terms. So this is x cubed and x squared, and the greatest x to whatever power that goes into both of them is an x squared. Because x squared divided by x squared is 1, and x cubed divided by x squared is equal to x. If we go up to x cubed, it's not going to divide pretty into x squared. So the greatest common factor, therefore, is going to be 9x squared. And we're going to do the same thing over here. The greatest common factor between these two, well, we can ignore the x because this is a constant here and it doesn't even have an x. So we know that our GCF is just going to be a constant. And we're going to look at the coefficient of this term and then just this term alone. And it's going to take some time, but you'll eventually figure out that the greatest common factor is negative 15. Negative 15 goes into negative 96 times. Yeah, 6 times, and then it goes to negative 105 7 times. So that is going to be your greatest common factor between these two terms. And then our next step is going to be rewriting these two sets of parentheses with the greatest common factor pulled out. So I'll show you what I mean. So we're going to write 9x squared. We're going to divide 63x cubed by 9x squared, which is going to be 63 divided by 9, which is 7, x cubed divided by x squared, which is going to be x. We're going to do the same thing with 54x squared. 54 divided by 9 is going to be 6, and then x squared divided by x squared is going to just not give us an x term. Afterwards, we're going to do the same thing on this side. We're going to have our negative 15. We're pulling that out, and we're going to divide both of these terms by it. So negative 105x divided by negative 15 is going to give us positive 7, and we got to bring the x down. And then negative 90 divided by negative 15 is just going to give us positive 6. Something I want you to look at. We pulled out these greatest common factors, but if you see the two sets of parentheses are identical, that is our ultimate goal in grouping. If you learn nothing else but this, that is our ultimate goal. We're trying to get these sets of parentheses after we pull out the GCFs from the two groups to be identical to each other, because that's how this factoring by grouping will work. If these are not identical, your factoring by grouping is not going to work. So make sure that when you're doing these problems, they match. Next thing we're going to do is we're going to end up having two sets of factors, so two different parentheses. In our first set of parentheses, we're actually going to take these two GCFs and mush them together. So I'm going to put the 9x squared here first, and then I'm going to add the negative 15, and that is going to be our first set of parentheses. So I'm mushing these two together. Then we're going to put the two sets of parentheses here that were identical to each other. So I'm just going to write one of them, so 7x plus 6. And here, and this would be our final answer. However, if you can see from this set of parentheses, there's actually a GCF again that you can pull out. In this case, if you look at the coefficients, 9 and this is just going to be a constant, it's negative 15. Well, their greatest common factor is 3. So I'm going to pull out a 3 from both of these. So our final answer is, after I pulled out that 3, 9x squared divided by 3 is just going to give you 3x squared. Negative 15 divided by 3 is negative 5 times the 7x plus 6. So that is how you are going to factor this problem. That is factoring by grouping, and we're going to do 2 more examples, I believe. Yes. Okay, next example. This actually doesn't take that long. So factor the following: 21xy plus 15x plus 35ry. I want you to look at this. So we have an x here, we have an x here, we have a y here, and we have a y here. But here in this situation, we have an r and we have another r. So we have 3 variables. We have x, y, and r. So keep that in mind. Here's your solution pre-written for you. For all of you who want to copy it down, I'm going to be running through this exact same thing again with you. All right, so first let's rewrite the problem. So the polynomial we've been given is 21xy plus 15x plus 35ry plus 25r. You can see these are all linear terms. They're not constants. They all have variables, blah, 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 blah. We can easily see that from this, just identifying the properties of the polynomial we're working with. Next thing we want to do is we want to group these. So what I would do is I would look at these and think, how am I going to group them? Do I need to rearrange this polynomial so I'm grouping two terms that are not next to each other right now? Well, I can't just randomly group either, because if I just randomly group, and let's say I put the 15x and the 35ry together, am I going to be able to GCF out anything except a 5, because that is the common factor between the coefficients? Because look at the variables, it's x, r, and y. We're working with 3 completely different variables, so I need to be smart about the way I group them. So the way I'm going to group them is I'm going to put the terms with x's in one set of parentheses. So I'm going to put 21xy plus 15x together in one set of parentheses, and then we're going to put the other two with r terms together in the other set of parentheses. The y doesn't really pose a problem because it's present in both set of parentheses, so I wouldn't worry about it. Plus 25r. So now we got to GCF, so we got to figure out what our GCF is. Let's first look at our coefficients, 21 and 15. You can easily see that the GCF is 3, 21 over 3 is 7, 15 over 3 is 5. So our coefficient of our GCF is 3. Now we got to look at the variables x, y, and x. If you compare these, what is the greatest common factor? Well, it's an x. I can plot an x from here, and I can plot an x from here. They both share an x. Can't pull out a y because the 15x doesn't have a y. Let's do the same thing with the second set of parentheses. So if I look at the coefficients, 35 and 25, my greatest common factor is 5. 35 divided by 5 is 7. 25 over 5 is 5. So we're going to have a 5. If I look at their variables, r, y, and r, I can plot an r at most. Can't plot a y because 25r doesn't have a y. So these are going to be my two GCFs. I'm going to rewrite these set of parentheses with the GCFs in front. So 3x, 21 divided by 3 is 7. Xy divided by x is just going to leave us with y. 15x divided by 3x is just going to give us 5 because the x's will cancel out. Plus, I'm going to put my GCF in front, 5r. 35ry divided by 5r, well, 35 divided by 5 is 7. R's will cancel out and just leave the y. Plus, 25 divided by 5 is 5, and the r's will cancel out again. And as you can see, we've achieved our goal. We have gotten the same expression in these two parentheses, 7y plus 5. And what I can do as my final answer, I combine the GCF here with the GCF here in one set of parentheses, 3x plus 5r. And the second set of parentheses will contain 7y plus 5. And this is our final answer. All right, one more problem, and this one's going to be a bit challenging. I suggest you stick with me because I did see this problem on an assessment that I did, or a very similar problem on an assessment I did, not the exact same problem. So if you are in a higher level Algebra 2 class, I would definitely suggest sticking around to see this one. All right, so here's your problem. Factor the following: x squared minus y squared plus 2x plus 2y. So we have two quadratic terms, and we have two linear terms here. We have an x and a y, so just two variables we're working with. And here is your solution pre-written. We're going to be incorporating some skills that we learned previously, such as difference of squares in this problem, actually. So it's going to be kind of interesting. All right, so let me go through this problem with you. And I promise it's not too difficult, but it's just a concept that you kind of have to memorize because you might see a problem like this in the future, especially if you're in a higher level Algebra 2 class. So I'm rewriting the problem, x squared minus y squared plus 2x plus 2y. The first thing I want to do is I just want to immediately jump in and group it. So what I can do here is I can group the x squared minus the y squared together, and I can group the 2x and the 2y together, just because these two look very similar to each other. They're quadratics. They'll probably work out. So it's almost like a guess and check method. So I'm going to group those two together, and then I'm going to group the 2x plus 2y together because I can pull out a 2 from both of them. Then I want to identify their GCFs. Let's just do this one first. So the GCF of these two terms, well, they both have different variables, so it's not like I can pull out an x or a y because the other one doesn't have that variable. But I can pull out a 2 because their coefficients are the same. So our GCF is just going to be 2. In this case, however, we can actually use difference of squares. Difference of squares and actually factor this. So we don't need to just pull out a GCF because we don't actually have a GCF in this situation. We can use a difference of squares. And if you remember, difference of squares was where you had two terms, a squared minus b squared. In this situation, a squared is x squared, and then y squared is b squared. And this is going to just equal a plus b times a minus b. Or you can write it the other way, a minus b times a plus b, doesn't matter. So if I do that, I'm going to have x plus y times x minus y plus, if I pull down this GCF, if I put 2 in front, well, 2x divided by 2 is just going to be x, and 2y divided by 2 is going to be y. So I pretty much just simplified this set of parentheses up here. So what am I going to do next? Well, I'm going to look at these two. I'm going to just draw a little dotted line here. These are like my two sets of factors, if you want to think of it that way. Well, if you see, there's an xy that is shared between both of them. So I'm actually going to write the xy first. So what our goal with factoring is to get that same one set of parentheses on both sides that match. So in this case, it's x plus y and x plus y. So what are we going to do with the rest? Well, in this situation, we're going to mash them all together. So in the second set of parentheses, we're going to have 2. I'm going to bring the 2 down, but then I'm going to put the x and y, negative y, I'm going to attach it like a tail. So I'm going to add the x and then the minus y. Make sure you pay attention to the signs. And I'm just going to mash the GCF from the right side to x minus y from the left side. I'm just going to mash them all together in one set of parentheses, because if you see x minus y didn't have like a matching set of parentheses, we did not have an x minus y. On this side, we didn't have that. Instead, we had an x plus y. Because it doesn't match, we're gonna mash it together with the GCF of this side. So if you actually multiply this all out, you are going to get the polynomial x squared minus y squared plus 2x plus 2y. So that's how you would solve that. I just want you to keep in mind that I actually wrote this. You need to combine these two terms here when you have a situation like this. You need to combine the 2 with this x minus y as we did in this second set of parentheses. So just keep that in mind. You're going to have to combine them together when you have a situation like this. Alright, that's all I have for you today. I hope you enjoyed the video. It was really fun to make, and I hope this set us up so that in our next lesson, when we're just looking at just general factoring of polynomials, you're super comfortable and you can apply all the skills you learned and just dive right into it. If you enjoyed this video, please give it a like and subscribe to our channel. Hit the post notification bell, drop a comment down below, and share using our socials. Check out our website and email us at our Gmail for anything at all. Thank you for watching, and I'll see you in my next video. Bye!